everyone. So today we're going to be talking about ions, which are what atoms become when they gain or lose electrons. Now we've talked about ions before, but we're going to talk about them in a little bit more detail today. So I want to review a couple of things with you first. The first thing is valence electrons. So you need to remember that you can determine the number of valence or outer energy level electrons from the column that an element is in. So for example, everything in this column has 1, 2, okay, so you can see this diagram. It goes 1, 2, we skip the transition metals, 3, 4, 5, 6, 7, 8. That's valence electrons. The other thing you need to remember is the octet rule. And that rule says that most of the elements on the periodic table would like to have 8 valence electrons. They want to be like the noble gases. It happens to be very stable for elements to have 8 valence electrons. So let's look at a couple of examples, and we're going to talk about how the elements are going to get 8 valence electrons. So take fluorine, for example. Fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So it looks like this. There's fluorine. You can see there's 7 in its outer energy level. It would like to get one more electron right there so that it can become like neon, so it can become like a noble gas. And there are ways for it to do that. We'll talk about how it does that in a second. But when it gains that one electron, it's going to become stable. It's also going to become charged. And since electrons are negative and it has gained one negative electron, it is going to have a -1 charge. And that actually is true for anything in this column, because since everything in this column has 7 valence electrons, they all want one more. So they're all going to form -1 ions when they become ions. Now you can probably guess that everything in this column, which has 6 valence electrons, is going to want to gain 2 more electrons. And so when they form ions, they're going to form -2 ions. And then everything in this column is going to form a -3 ion. That's how it works on this side of the periodic table. So you can predict the charges by the column that the element is in. Now let's look at the left side. Let's look at sodium. So sodium has 1 valence electron. Here's what it looks like. So you probably are thinking, well, maybe sodium wants to gain 7 electrons. Turns out it's really hard to gain 7 electrons. So what sodium can do instead, that is much easier, is it can lose an electron. It can lose this electron, and then it will have 8 electrons in this shell beneath it. So everything in this column actually wants to lose 1 electron and become a +1 ion. So these ones will become +1, these ones will become +2. These ones will all be positive. They're all going to lose electrons, but their charges are not predictable. So we skip over. Things in this column will lose 3 electrons to become +3 ions. And then things in this column, they would either have to lose 4 or gain 4 electrons, and both of those are hard to do. So they don't form ions very often. Okay, but there is a pattern you can see, and I'm going to show you in this diagram. The charges on the periodic table, when these elements form ions, it goes +1, +2, skip, +3, skip, -3, -2, -1, skip. The noble gases don't form ions because they're already stable. So I tell people to always remember 1, 2, 3, skip, 3, 2, 1, skip. Now you might be noticing there's a couple of transition metals that are always predictable. Zinc and cadmium are always +2. Ag, which is silver, is always +1. You don't need to have those memorized, but if you're curious, you can know that. This paper, I gave people in class this paper that they could glue in their notes. So if you want to come get this from me, it's pretty helpful. It's got the charges, the valence electrons, and a couple other things we're going to talk about in a second. All right, so you need to know these trends. 1, 2, 3, skip, 3, 2, 1, skip. Now a lot of that might have been review, because we've talked about some of that before. So we're going to get on to the new stuff. So I printed this out for people to take notes on. So again, you can come get this from me, or you can just write down what you can in your actual notes. I'm going to zoom in here on this. All right. So we want to learn how to name these different ions. So we're going to start with cations, which are formed by metals, and they are positive ions. Okay, we've learned that before, but just so you can remember. cations are positive. You can remember cats are good. We like cats, so cations are positive. Maybe you don't like cats, sorry. Okay, so the rule is for main group cations. Now let me tell you what I mean by main group. So the main group cations are ones that are not transition metals. So that would be these columns right here. That would be like aluminum and gallium. So just mostly these two columns and a couple over here. For those cations, you just give them the same name as they already had. So for example, Na+, which is a main group cation because it's right there, its name is going to be sodium. It's pretty simple. Okay, now if the cation is a transition metal, there's an extra rule. You give it its name, but then you have to write the charge in Roman numerals. And the reason you need to do that is that they can have more than one charge. For example, this is iron. It can be a 2+ or a 3+. So if it's a 2+, we write iron 2. If it's a 3+, we write iron 3. Okay, so you need to know your Roman numerals up to 4. So if you don't know that, Roman numeral 1 is I, Roman numeral 2 is I, Roman numeral 3 is I, and then Roman numeral 4 is IV. So just need to make sure you know that. Okay, so that's how you name all the metals, the cations. The anions are the nonmetals, and they are the negative ones. And they're on the right side of the periodic table. So if the anion is just one element from the periodic table, for example, if it's chlorine, you change the ending of the name to "ide." So instead of being chlorine, Cl- is going to be chloride. So that's how we get names like sodium chloride. Or fluoride in your toothpaste is fluorine as an ion. So we're going to change the ending to "ide." Okay, now one more big concept. There are these things called polyatomic ions. So polyatomic ions are ions that are made of more than one atom. And the atoms are sharing a charge. So for example, there is a polyatomic ion called CO3. And what it looks actually like this. So these lines are like electrons that are being shared. And basically, this one carbon and these 3 oxygens together are a -2 charge. Okay, so it's not like each of these has a -2 charge. This whole thing as a whole has a -2 charge. And there's specific names for each of these polyatomic ions. And there is a chart that I will let you glue into your notes. That you can use to look up their names. So for example, CO3 2-, this is our polyatomic ion chart. If you find CO3 2- on the chart, it's in the 2- column, you can see its name is carbonate. There's no way you would know that other than looking it up on the chart. So if you have an ion and it's made of more than one element, you just need to look it up. Couple things I want to point out about these polyatomic ions. You'll notice a lot of the endings of their names are "ite" or "ate." So if you ever see anything with "ite" or "ate", it's probably a polyatomic ion. There are a few exceptions. Hydroxide ends in "ide", cyanide ends in "ide", but the rest of them you can see sulfite, sulfate, carbonate, oxalate, silicate, these all end in "ate". And they're all either -1, -2, or -3, except for there is one positive one, which is ammonium, which is a +1. All right, so this is an important chart to have. So let's just do a couple of practices and then we'll be done. So if we look at magnesium, we want to name the ion magnesium 2+. So it's a cation because it's positive. So our cation rules say it's either going to just have the same name or it's going to have a Roman numeral. Magnesium is just in the main group, so it's just going to have its normal name. So it's just going to be called magnesium. Let's try F-, that's fluorine becoming an ion. It's an anion, it's just one element. So we just need to change the ending of its name to "ide." So it's going to be fluoride. Okay, Cu plus, that's a cation. Let's see if it's main group or transition metal. Oh, look, it's a transition metal and it's copper. So we're going to need to put the charge in Roman numerals. So it's going to be copper 1, because its charge is +1. Lastly, this is chlorine and oxygen. Oh, so that's more than one element. So if it's polyatomic, if it's more than one element, I need to look its name up on this chart. Oh, and here it is, it's chlorides. So ClO2 minus. Name is chloride. And again, I just had to look that up. All right, so that was probably a lot of information, but that is how we name cations and anions.